Good morning, everybody. Thank you for joining us. We have a presentation today from Mr. Gavin Loyden, the Managing Director, and Tim Wall, the Chairman of QEM Limited, who'll be walking through the latest company presentation, Advancing the Julia Creek Project. Following this, there'll be time for some questions at the end. So I'll hand it over to you, gentlemen.
Thanks, Peter. Thank you. So I'll kick off and give you an overview on our project, and then I'll hand over to Gavin partway through the presentation. So just advising people that we are recording this morning. We will run through the presentation and then we'll take some questions at the end. So thank you for your interest in the project. We have a world-class critical minerals and oil project with a large resource. We have recently completed our scoping study with strong economics. We'll talk through that today. One of the key drivers in our scoping study spreadsheet is a 4-step 3-way separation at the front of the project, which Gavin will talk in a bit more detail, to create a concentrated feed to the vanadium recovery facility and the oil refining facility. And we are looking to secure funds through our entitlement offer process to complete our technical studies, lock down our flow sheet and enable entry into the PFS. So disclaimers, as you would expect, in relation to the offer and the scoping study. So as I said, we're focused on the exploration and development of the Julia Creek project, a unique world-class critical minerals project. We have a significant resource, 2.8 billion tonnes in the inferred category and 461 million tonnes in the indicated category for vanadium. It's one of the largest single vanadium resources, and we also have significant oil resource in the shale. We have 654 million barrels in the 3C, 94 million barrels in the 2C, and we have a maiden 1C resource in this year's JORC update of 6.3 million barrels. So very, very large, very significant resource. So this is the project. This is from our scoping study. You will see that we have in the top of the tenement a pit design there. So that's 30 years worth of processing as per the scoping study. You will see that that 30 years only occupies a relatively small part of the tenement. So we have lots of resource there to potentially extend the life of the project. The green area down the bottom is the associated renewables project, which we developed by Enel Green Power Australia. That dotted dashed line at the bottom is the copper string, a high voltage electricity transmission line, which runs right past the project and the renewables precinct. We are located close to the main transport links between Townsville and Mount Isa. So at the top of the map there, you will see the Flinders Highway and the rail. Our intention is to locate our processing facilities and logistics in and out right next to the rail and the road, which is a relatively short distance from the pit. So let me talk about some of the highlights of the scoping study. So as I've said, life of mine 30 years, run of mine 5.1 million tonnes, delivering an annual production of just over 10,000 tonnes of high purity 98% V2O5 and 330 million litres a day of transport fuel. The project economics are very strong. Post-tax NPV of $1.1 billion, 16% IRR, which is very attractive for a project of this size, and a 5-year payback. I won't go through too many more details in this slide. This is all available in the scoping study. Over our 30-year mine life, 80% of the process is already in the indicated. Around 7% of the fuel that we produce as transport fuel will be free issued to the mining contractor for mining. We've got the cash costs in there on the previous slide split between the two commodities. We are predicting V2O5 sell price for the 99.5% battery grade of around $11.56 a pound, and transport fuel around $1.20 a litre Australian, excluding excise and GST. I'll just talk a little bit more about the commodity pricing. But before I do that, I'll just give a little bit of context around vanadium. So vanadium is a critical mineral. Australia has 30% of the world's resources, split roughly 50-50 between Queensland and Western Australia. So Queensland is around 15% of the world's vanadium resource. That is concentrated in the Julia Creek Richmond area, of which you'll see the blobs there in the Julia Creek Richmond area, and our deposit, which is tagged Julia Creek, is the largest of those. So we have the largest resource. We're expecting an eightfold increase in vanadium demand by 2050. You'll see on the right there's a chart from the World Bank showing, lithium for mobility, for vehicle batteries, and vanadium for large stationary grid-scale batteries, both growing substantially to support the energy transition and the decarbonisation of our transport infrastructure. So we're expecting batteries, well, this is forecast from Vanitec, batteries to be 25% of the vanadium market by 2040. So the majority of that strong growth in vanadium will be driven by demand for batteries. Current world production is 125,000 tonnes of V, which is around 250,000 tonnes of V2O5. And as you see, most of that current production comes from China, with small amounts coming from Russia and South Africa. So vanadium is a critical mineral in Australia, in the US, Europe and Japan, both through its necessity in the energy transition, but also its importance in defence applications for anything that goes supersonic. So just a little bit on pricing before I hand over to Gavin, just so you can get a feel for the assumptions, the robustness of the assumptions we've used in the scoping study. So we have, on the left-hand side, this is the historical distribution of commodity grade vanadium pricing. So that's the 98.5% grade. So 75% of the time, the mean price of the 98% grade has been between $7 and $13 US per pound. The average over that period is, the mean over that period is 10.28. That's 0.2 on that chart to the right. So we've looked at the lower range, we've looked at the median price, and we've looked at some future prices for the 98.5% grade. And we have applied a 10% premium to that for the 99.5% grade, which gives us our $11.56, which is the price point you see there on the study. But very much within the, within the range of historical pricing, with the adjustment for 99.5% battery grade compared to that historical pricing, which is the 98.5% commodity grade. Yeah. And just in terms of the fuel pricing, so we've kept this relatively simple. We've used a Brisbane wholesale diesel price average over the last 3 years of $1.20 a litre. That's excluding excise and GST. And if you look at the more recent pricing, it's $1.21. So we think that's a reasonably robust and simple assumption for our fuel pricing. So, I guess before I hand over to Gavin, in summary, we have a world-class multi-commodity project. We believe we've made some conservative and reasonable assumptions around the pricing of the commodities. We've got very strong economics coming out of the scoping study. As I said, $1 billion NPV, 60% IRR and 5-year payback. So that's the highlights from a commercial commodity point of view. I'll hand over to Gav to talk a little bit more about the details of the project and what we've done in terms of de-risking.
Thanks, Tim. All right, well, let's have a look at the processing for starting here. So what we're looking at, and as Tim pointed out, we've got a ROM of about 5.1 million tonnes per year. The trick to this project is the beneficiation and the rejection of calcite, because an acid consumer in the vanadium extraction process. So what we're doing here is we're separating the limestone, getting rid of that material. That's going to leave us with a concentrate after kerogen separation, and that's a flotation process. So we'll only have about 400,000 tonnes going through that part of the unit. And then for the oil extraction itself, we'll be following this line here. But let's stick with the vanadium for a moment, and that's tracking across the top here. So we're again floating off the vanadium, and we'll have about 1.1 million tonnes going through that circuit. So 5.1 million reducing to 1.1 million through vanadium circuit, and only 400,000 tonnes as a concentrate through the oil extraction process. And we've got a way of doing this, that is very, very sensitive to environmental conditions. So it's a supercritical process, and that allows us to get more than is estimated in the MFA, which is how the in situ value of the oil is produced. So we use green hydrogen. We turn that green hydrogen into a hydrogen donor solvent, which is part of this process. And in supercritical conditions, that attaches to the hydrocarbon chain. And then we secondarily hydrotreat that raw oil that we've produced with further green hydrogen to produce a transport fuel product. And our objective here is a low sulfur diesel. And we'd be looking at producing about just over about 900,000 litres a day. That sounds like a lot. That's around about 4% of Queensland's consumption at the moment. Queensland's consumption for diesel has gone up 180% in the last decade, and it seems to be growing at a fair clip. Queensland is again the highest producer of, the highest consumer of diesel in the country. And that's because of the amount of mining and so forth that's going on, and is predicted to go on from here as well. Now, if we go back to the vanadium, as Tim rightly pointed out, we're looking at a 99.5% purity. That differentiates us a little bit from some of the other proponents out there. They're all looking at doing a 98.5. 99.5 is battery grade, and that's our focus here. Queensland owns the network here, owns the grid, owns the production and the distribution and sale of energy. And with that in mind, they will also be the owners of the batteries. And we need about 15 gigawatt hours of storage in Queensland alone. It's about over 150, I believe, nationally. To give you some indication, our output of 10,000 or 10,500 tonnes per year of high purity would be 1 gigawatt hour of storage. So for us to just capture the Queensland market in its entirety would be 15 years of processing for us. So that allows us to be quite, work quite closely with the other proponents as well, and take a very much a common user approach to things like water and power. And I'll speak to that a little bit more in a moment. So we built a pilot plant to demonstrate this at the next level of scale, and this resides down at HRL's laboratories down in Victoria. So this is this supercritical processor that we mentioned. This is a 25 kilo batch process, but we've successfully produced the raw oil from this process, and we did get that 180% of what it says is in the ground. So if we're looking at 60 odd litres in the ground, we're close to double that once we've extracted the oil from the material. We're well ensconced in our environmental process. Our PFS should be quite a compressed program, given that we are, more than 12 months into our environmental. We've done flood modelling, we've done baseline environmental work, we've done a full geographic survey. So there's a lot of work that's already been achieved. So that leads us to believe that we can shorten down our PFS project process somewhat. Power was our initial concern out there, because there was less than 2 megawatts of power available in Julia Creek. So what we decided to do was very early, back in 2021, we decided to put up a 160 metre met mast to measure the wind conditions and wind speeds, solar and solar measuring equipment. You can see us out there with the minister on site. And we needed 12 months of that data to have any indication of the viability of a renewables project. We obtained that data. It was over and above our expectations, and then we put out to tender this project because it was not something that we were prepared to take on ourselves. Our requirements for power are nowhere near a gigawatt, of course, but it was suggested to us by the copper string developers that if we made it a gigawatt, we would get a much better audience engagement with the big guys. That turned out to be very true. We had 15 apply. We narrowed that down to 3, being Acciona, Origin Energy, and Enel Green Power Australia, and we went with Enel, mostly because of their capacity. They're one of the largest wind developers globally. They own their own panel processors, and they're getting into vanadium batteries. So you can see where the synergies lie there. The partnership that EGPA is comprised of is Enel Green Power, which is an Italian group, and Inpex, which is the Japanese oil and gas conglomerate. So again, you can see there's some synergies between why we've made that selection. We received $3 million back in January for the sale of the equipment and the data. We've got some other payments coming, the contingent milestone payments, the neighbourhood of about $4 million out to FID. And when Enel goes to FID, then there'll be a more significant payment of around $20 million, and then 2% royalty for 30 years and 1% for the balance of the 40 years of the project. So obviously the intent for us was to get cheap, reliable power, and we've got a 10-year agreement with them for that. So that is now, that is developing that project. And hopefully we'll have power meeting the timeline of the delivery of the copper stream project in Julia Creek, and as Tim mentioned, that's a $5 billion poles and wires project that's been acquired by the government from the developers, and that is underway as we speak. So there's been strong support from government. As I mentioned before, we work quite hand in hand with a lot of the other proponents out there. That common user approach, I think, is quite novel, I think, in Australia, but it's certainly the way forward for developers, not just for us, but for others, because what it's allowed the Coordinator General to do in Queensland is come across and create a critical minerals zone, with obviously vanadium being the primary objective. That allows the Coordinator General to speed up processes for proponents out there. It also allows for universal baseline modelling for social engagement. It also helps with universality around environmental work as well. So taking the example of the gas industry, what government didn't want to see was a cookie cutter of the same thing, everyone spending the same money, coming up with the same results. And because it is so uniform out there terrestrially, then we can make those things a little bit more universal, and we can all enjoy the results of that without having to all do the same work and spend the same money. Now, when you're doing a project of this dimension, obviously you need the skill set on the board that has the skill, the history, and the ability to engage with what we will need to look at as for strategic partnerships going forward. So Tim obviously is an oil and gas expert. He's over 35 years in refining and fuel experience. The ex-MD of the Bull refinery here in Queensland, but global experience through IPL in hydrogen, ammonia, and chemical processing. So Tim is our energy guy. Daniel Harris, over 40 years of global experience in vanadium, was the ex-vice president of Evraz, one of the largest vanadium producers globally. That was a $4.6 billion pound, I should say, company that he was vice president of. Daniel also sits on the board of US Vanadium and an AVL, an Australian Vanadium in Western Australia. There's no conflict there because they're completely different ways of processing this material. But Daniel has walked on every project globally. He has actually built projects from the ground to delivery in the vanadium space, and he's regarded as one of the global experts, if not the global expert for vanadium production. There's myself. I'm the founder of the company. I put the project together, raised the early capital for it, and then brought it through to where we are today. And Tony Pearson, Tony Pearson's our money man. He's ex-managing director of HSBC in Hong Kong. Been on multiple boards, understands markets very well. So we think we've got the right skill set to deliver this project, but obviously we will be looking for some more strategic partnerships as we move forward. Corporate snapshot. So, you can see that we've got a reasonably low market cap, or a very low market cap under these circumstances. That seems to be true of most critical mineral projects in Australia at the moment. They're not quite getting the value that you would think would be the case, being that they're critical minerals. And they're critical for a reason. We absolutely need them to move forward into this energy transition. And without them, there will be no energy transition. There's vanadium batteries are probably the only real solution to grid support here in Australia, because they can operate effectively in Australian conditions and for a long period of time. So undervalued. I mean, the rule of thumb for a scoping study of this sort of dimension is about 10% of the NPV. So you can see we're significantly undervalued at the moment, but we hope that will change for us in the very near future. It's a very tightly held company. We've got nearly 73% is held by the top 20. It does make liquidity a little bit tight, but nevertheless, it does show the strength of the register that we have at the moment, because people want to invest, they really want to sell. So this is where we are timeline-wise, and the project implementation schedule. This is the shortened version out to 2026. I'll let you digest that at your leisure through the recording. This is probably a little bit more descriptive in the timeline. We have just completed the renewable sale. We've completed the scoping study. Getting those things through ASX and ASIC at the moment is challenging, and we met that challenge and had no issue with that. We've got a little sideline project that we worked on as well. I won't spend too much time on, but it's actually taking vanadium from spent catalyst from the acid industry. We're moving into pre-feasibility now. As I said, we've done a lot of work that would probably be considered pre-feasibility work, things like building pilot plants and moving forward with our environmental. We've applied for a coordinated project status for this, and we've got the EPBC referral going in next week. We expect to complete PFS in 2026 with EPA authorities, and mining lease, DFS leading into 27, construction in 28, and production in 29-30. So our immediate milestones are to complete the test work that we're undertaking right now with UQ and Core Resources. Get all that work out of the way, make sure that we have our flow sheets optimised, and then move forward straight into the PFS. So we've got a very strong plan and a strong pipeline of work. And I think that's us. Let's go back to the slide. Yeah. Happy to take any questions there might be.
All right. Thank you, Gavin and Tim. Pretty comprehensive and a slick presentation, really setting the company up for the next phase. We've got a few questions that have come through. The first one that I'll kick off with is a question regarding vanadium redox batteries versus lithium-ion batteries and the appropriateness for the Australian environment.
Yeah, I'll take that one, Tim. Yeah, absolutely. I think it's a fundamental question. Given that the lithium was the first mover here in Australia through Tesla and Elon Musk, the project down in South Australia. Look, lithium has its place. I'm not sure the grid is that place. They can be a little bit tenuous at large scale, and particularly in Australian conditions and in European, North American conditions. They don't operate well at low temperature. They don't operate well at high temperature. They have safety issues. The last couple that we've tried to start in Australia have both ignited, which is not a good place to be. So we see, and I think if you look at the Chinese experience, you'll see what they have done there. Lithium is for portable electronics and EVs, and that's where it's best suited. Vanadium is for the grid. And China has just announced another 7 gigawatt hours of storage via vanadium batteries. This is their choice for this system. They work great as a load leveling battery as well, because they can charge and discharge at the same time. They're safe. They, as I say, operate in Australian conditions. They're recyclable, 99% recyclable. the electrolyte that we would look to produce to go into these batteries has less than a 1% degradation over 30 years. So you can actually take the battery out of, take the electrolyte out of a 30-year battery and put it straight into another one and go for another 30 years.
I guess the summary is it's not really an either-or question.
Correct. Of course.
Vanadium, yes, vanadium is well suited for high energy density, shorter duration batteries.
Yeah,
anything that's mobile is more likely to use lithium kind of technology. Vanadium is very well suited for larger and much longer duration batteries.
Yeah,
so we're talking, you know, except the recent Rocky Power just announced a 175 megawatt, 700 megawatt hour battery. You know, that occupies a football field. That's the sort of thing we talk about with vanadium batteries. So much larger, much longer duration, more suited to supporting the grid. Whereas lithium is much more for your smaller mobile applications.
Yeah, that's right. And particularly when you're talking large scale up to a gigawatt, that's really that's really where we see this, and Australia has the need for it. There's obviously a global opportunity here as well, but the immediate opportunity is right here in Australia, and that's where we see us headed at the moment. But having that 99.9% gives us the flexibility to go into those exotic spaces like aerospace as well, where you need that level of concentration. Anything that goes supersonic speed needs vanadium in the alloy, and that's irreplaceable in that space. And as we go to hypersonic, you're talking up to 20% vanadium. So massive impacts in the market. While we're on the market,
let's get to the next question.
Yeah, sure. Okay.
That's right. We have another presentation another time. A good segue on the batteries. Given Australia has significant vanadium resources, probably 30% globally, what other countries on the planet have advanced their vanadium battery technology? What's some good examples that we can look towards?
Well, there's over 300 large-scale systems globally at the moment, and they're growing. I think the number was about 150% in the last 2 years. So it's the growth trajectory of the VRBs that is the most compelling part of this story, because even the more conservative pundits are talking about a 200% growth, and other pundits are talking up to 8 times. So it's a huge opportunity. It'll change the dynamics, and it already is changing the dynamics of the vanadium market very quickly.
And it's interesting, if you look at China, that has a very big energy transition challenge, and has access to both lithium and vanadium production because they're a leader in both. You very clearly see them announcing a lot of large, long duration vanadium batteries. So I think that's probably the best indication of what the split's likely to be between lithium and vanadium, is what you see China doing, because they have the scale, they have a large transition to do, and they have the access to all the technologies.
Exactly. Yeah.
And we can learn
and
from
I think you'll
their,
find that just recon. Yeah.
And I guess we can learn from their mistakes and successes. Now, further to that, there is a great downstream opportunity here in Queensland, which seems to be supporting the industry probably more so than other states. What is the opportunity for downstream vanadium battery production in Australia? How do you see that panning out?
Well, really, I think it's worth pointing out that this is an Australian invention, by the way, developed back at the University of New South Wales back in the early 80s and enjoying its 40th year anniversary this month. So it's an Australian technology that we can go from pit to product.
Yes.
And it's the only battery that we can build from dirt to the battery itself. It's the only one that we have capacity for. We've got plenty of it. It's a single element battery, so you don't need cobalt, you don't need nickel, you don't need manganese as you would do in lithium. And they're different flavor. Vanadium we have total control over. Here in Queensland we have less of the metal contaminants as well because it's a sedimentary deposit, so it doesn't have the ions and the titaniums that can be a little bit problematic in electrolyte production. So the opportunity is here and it's now, and that's why we say it's the right project at the right time.
And the Queensland government has some initiatives there with the battery testing centre. How helpful are they in making perhaps global introductions to engineering firms who you might work with going forward?
Extremely helpful. The government's building what's called the Queensland Resources Common User Facility, again taking this common user approach, and we went to them a few years ago now, about 4 years ago, to take this approach as a group. And they're supporting that by constructing a $75 million common user facility in Townsville that will give us the ability to scale to that pilot level. And then, yes, absolutely, government will then provide some of the financing and financing support and introduction to global off-takers and global developers.
And they also, as you say, they have the battery testing facility. Energy Queensland currently has a vanadium battery, which is about to be commissioned, I think.
That's right.
Or, where they are going to put one under test and put it through its paces as well. So, and as to reinforce what Gavin said, vanadium battery is a one commodity battery. So, once you have mined and refined the vanadium as we can do locally, then you need an electrolyte plant, which is a reasonably simple process, and then the battery itself you can build here. So it's very much a technology from, as Gavin said, heat to battery that's fully achievable in Australia.
Yeah, and we have produced from our material a 99.9% product, so we have no issue with the technology that we're using.
Yep.
Now, onto the commodities. It's an interesting project given its dual commodity nature and very different types of quantities. How do you see the potential off-takers for the two products, as well as the downstream for the vanadium? And is there opportunity for joint venture with those off-takers to help you develop the fund and develop the project?
Well, I'd say there's probably three likely off-takes for the project. I mean, as Gavin said earlier, our fuel production is sort of 4% in Queensland's demand. That's not going to go terribly far from where it's produced. And in discussions we've had with, the current market players, they see that demand persisting for quite a long time in the future.
Yes.
So we think the fuel offtake will be probably separate from the vanadium offtake. Vanadium offtake, there are likely to be two main customer segments. One is the obvious batteries for the east coast of Australia, where we can, as we just said before, we can actually produce the high purity vanadium, the electrolyte, and produce the batteries here. That set of customers, when Queensland, that customer is primarily the Queensland government because they own the electricity system. Obviously, in the other east coast, there's a combination of government and private. So there's a good chunk of this is likely to go into batteries to meet the Australian requirements. And then there's potential offtake of 99.5% pure product exported out of Townsville to international customers. So probably three different off-takers, one for fuel, batteries locally, and then potentially international commodities, which, there is potential for some joint sales, joint marketing agreements there, but there's certainly lots of potential off-takes for both products.
The way we describe this is it's only regionally significant for oil production. It's globally significant for vanadium. And nice little addition to that is obviously we have defence up the road in Townsville as well. So there could be an opportunity as well that we will explore in the future.
And is there potential in the funding component of the project there for some joint venture off-takers to come in at the project level to assist with the engineering?
We're always looking for that sort of support.
Absolutely. When we have de-risked and developed the project to the right stage, when we think it's appropriate to bring in strategic investors, then there are potential strategic investors in all those categories, right? Fuel, international commodities, and local battery demand.
And we've certainly initiated some of those discussions already, so they're ongoing.
I think that's a good answer, because I think that's often the concern for shareholders or the market is when do you initiate those sort of discussions? And obviously you've done so, and also obviously you need to have those further studies completed so that you're at that appropriate timeline. Just a specific question here on the project, because, and I guess it's interesting given the location up there in Queensland where water is often an issue. Someone's just asked about the water requirements of the project and where you think you'll source that from.
Our base case at the moment is a pipeline to the Flinders River, and it's a flood and capture model. So as the river floods seasonally, it captures that as a dam close to the source of the river. We pipe that down to our project area, and we have a storage facility there. That's our baseline targeting at the moment. And we're looking at about 2.2 gigalitres a year is our consumption. We would actually apply for more than that. We'd want 2 years of storage on site, so it's probably like 5,000 megalitres if we were looking to get the licence for that. And again, the idea of having the Coordinator General sitting over the top of this precinct is to help streamline that process as well. So the support is there, but we do have a base case. We're working on different options on improving that, where it may be a combination of different opportunities on water. The water strategy is being reviewed at the moment out to 27. And again, all these things line up with our timeline.
Yeah, there's the potential for a common user water pipeline feed from Lake Julius, which has capacity. So there's been some investigation into that. Yeah. Done as with the participation of all of the proponents in the Julia Creek Richmond area in consultation with the government. So there's a couple of potential options for water.
Again, that common user approach, I think, is the way forward for industry in Australia. It certainly works here in Queensland. I think we're the envy of some others, and rightly so.
Right, we've got a few more specific questions, which I'll encourage people to email through to you, which I know you'll like to answer them. They're more detailed. I think you've covered most of the ones broadly across the question list here. Perhaps we'll just finish off with what are some of the near-term catalysts that shareholders can look forward to for the company?
Well, it's the end of this next piece of work that we're doing to optimise the flow sheets. Then obviously there'll be moving straight into PFS, so there's announcements around that. As I've mentioned before, we're going for a coordinated project status, which elevates the project and allows, again, the Coordinator General to accelerate and move departments at a pace. So all of these are significant pieces of work that we're working on at the moment. We've got the EPCB referral going in. Yeah,
so a combination of key project and flow sheet development milestones leading into PFS and key approval milestones in terms of progressing the approvals for the project, environmental and other approvals is what we'll see.
Exactly. Yep.
Plenty in the pipeline for shareholders and potential investors to look forward to. Tim and Gavin, thank you very much for your presentation here this morning. This video will be recorded and available to everybody very shortly later today. Thank you for your presentation, and thank you for everybody attending today.
Thanks, Peter. Thanks for your support.
Thanks, everyone.